everyone. So this is a super special event, as you can see, and that we have a special guest today. You will see him later on. And then we have also all our organizers of this fantastic meetup speaking today for you and sharing their thoughts for the first time in this meetup, in the history of the meetup at one stage. We tried to organize the offline event, but unfortunately the circumstances didn't let us. But anyway, we are meeting here online, everyone, and we can also join from different locations, not only from Berlin offline, and we are safe. And let's start. So why PyBerlin? Well, I'm not sure if there are many newcomers in here, but if there are, let me tell you a story about this fantastic meetup, how it started. We were thinking that we love Python. Well, it's a great language. Then we love sharing ideas, and we are based in Berlin now, online as well. And we are welcoming everyone interested in Python, sharing ideas or anything Python related, Python ecosystem related. And you know what? Python and Berlin, we know how to get to the top of the TU tower with Python, of course. So here are the organizers. You will see them around a lot today during the talks, during the question sessions, also hosting, moving around, and then feel free to chat with them and me, including, and also the speakers. We are supporting the Twitch chat and also here in the Zoom chat. And then if you want to just ask any question from anyone, just unmute yourself at some point after the talks, not during the talks, please. After the talks, we'll have a Q&A session, and then you will be able to talk and also write in the chat. So please be nice to everyone, including the speakers, organizers, and the participants. If you're interested and curious about code of conduct, feel free to read it from this link. And actually, it's safe to ask questions for the speakers and for the participants, because if you respect each other, just don't use some specific words like subtleism, and also no just, well, actually, and then no feigning surprises. Just respect everyone as speakers and organizers. They're doing all of this on the volunteering basis, and we are spending a lot of time to share the knowledge with you and meet with you online. And today's event is sponsored as usually by Scrapy. Today's agenda. We have a super packed agenda and even a bit more surprises for you. So let's start with the first speaker. It would be Maxime Lapan. He would be talking about scalable crawling with Kafka, Scrapy, and Spark. And then the second talk would be Luben Alexandrov. He would be talking about metrics for the quality of software engineering process. And then there would be me. I will tell you some hints and some secrets of domain-driven design. And then it would be Shreya. She will tell us her story from Python to product. And we are also looking for organizers. We are also looking for speakers. So if you're curious enough how to organize this meetup and how to help us, just contact us. We're not only looking for professional speakers, but we are looking mostly for everyone who is willing to share something with other people and also learn from the questions, maybe while preparing the talks. We have different talk formats. The full-time talk, which would be 30 minutes, and then the lighting format would be 5–10 minutes. And if you're interested at this point, as you're still looking at the slides, feel free to scan this code or enter the link and then submit your talk, or just maybe contact any one of us directly through Twitter or the emails or any other possibilities. And we would really love to see your tweets. Here's our Twitter handle, and then you also can subscribe to get all the news right away. here are the credits. We are super thankful that a long time ago, around, I think 3 years ago, those people and also those tools helped us to start with our fantastic logo and with our story of this snake on the top of TV tower. It was really great, and we're still grateful to all the people who contributed. So the first talk, please welcome our first special speaker, Maxime Lapan.
Hello, let me share my screen. Yeah, okay, so let's get started. My talk will be about our scraping project we have in Scalable, about its motivation, architecture, how we get to the point writing our own scraping infrastructure system, and everything related. Really short slide about myself. I have been balancing between big data and machine learning, trying to sit on both chairs, and currently working in Scalable, like between roles, like both architecture in data processing pipelines, working with ML models, architecture. Also wrote a book, Deep Reinforcement Learning Hands-on. It was quite a for fun experience, but if you're interested in reinforcement learning, you might check it out. So Scalable, just to give a bit of a context why we need a crawling at all. So core of Scalable business is a procurement intelligence, which at its core means we finding relevant suppliers for specific user demand and work with a lot of manufacturers like Audi and our car manufacturing companies, which basically having to find suppliers for thousands or maybe hundreds of thousands items to assemble them into final product. And it basically finding relevant suppliers, coming to answering questions about companies. What does the company manufacture? At what locations they have production facilities? Does the company have specific certifications? And a lot of this, and we are using a lot of machine learning to answer these questions. And we use, of course, internally lots of data sets, both commercial and open, to just fit it into a single puzzle. But most of the time, the best source of information is the company website, which is a messy wide web, and which is basically leading us to a main topic: how to crawl thousands of domains very, very quickly, as quick as possible. And the requirements to our crawler was a bit of contradictory. So first of all, we want performance. Some of our components require near real-time data acquisition from domain websites, from domains. So the faster we return the data from website we've never seen, the less time people will be waiting for demand results. It's not all our pipelines, but some pipelines require almost real-time data acquisition. So latency of crawling should be optimized. At the same time, we want efficient and we don't want to spend lots of money because we're still a startup, we're still growing, and the data volume is large, and basically we're supposed to crawl millions of domains and store terabytes of data. So the less money we will spend on this, the better. And second, next motivation is that we have lots of long tail domains. So because demand might require analyzing websites from manufacturers in the middle of nowhere, it might be some Chinese websites not translated to English, having broken certificates, working through HTTP, and never seen by Google. They might be seen by Google, but not available in some common crawl custom available snapshots. So like before starting the project, we've done quite quick checking of a landscape of existing crawling solutions and came to conclusion that basically there are two large classes of crawlers. They either fast and expensive to use. A very vivid example is Scraping Hub infrastructure, when they're providing like their own cloud to upload your crawler, and you can run them for specific websites. Either we have slow and efficient solutions when you're starting once a day your Hadoop job, which does a lot of data crunching, but no real-time data acquisition, nothing. They're efficient, but very, very slow from latency perspective. So we decided to write our custom crawler, and the main motivation of this talk, you might think, basically, okay, closed source solution, not available anywhere, but I still think it's useful for Python community for several reasons. First of all, it's an example of complex distributed system, how to design it, and basically fit lots of requirements into one single picture. Kafka and Scrapy, both open source, both really, really well integrated into Python, and they're really at the core of our solution, so it wouldn't be possible without them. And we might consider open sourcing our product later. There is nothing really fancy about it, so it's possible. But before that, you might write on your own using our guidelines and architecture decisions. So yeah, really quick overview of architecture. At the core, we have Kafka, and we use it as both a storage and a message transfer. So basically, Kafka is really good at fulfilling two a bit contradictory requirements. First, it provides really high throughput when you want to write lots of data into Kafka. It's really optimized to write lots of data volume per unit of time. At the same time, it provides really low latency. If your size of messages is really small, you can write them at quite large a large amount of messages. So it provides really simple load balancing of tasks. At the same time, it provides you basically combination of storage and message passing. So you can write your messages once, and lots of components in your system, not aware of each other, can read the same stream of messages over and over again if it's needed. So it's a bit like a replicated storage, providing really low latency message passing to you. And we use Scrapy for actual data scraping. It's a really wonderful open source library, basically like a Lego blocks for building your own scraper. And one of the decisions we've made, basically we're scaling on domains and not on URLs. And that's a bit of a cornerstone decision, because like scaling on domains, we're assuming that domains are relatively small. And if domains are not small, like New York Times, for example, which might contain millions of URLs, we limit amount of URLs we retrieve from every domain. And this decision basically make everything quite simple in terms of load balancing, because if you balance on URLs, you need to provide very low latency message exchange between your system just to pass URLs around. But if we work on domains and we have thousands of domains to process, it allows us to work on relatively large amount of tasks, which makes it much simpler. And we also use data processing pipeline, sort of. So which basically mean as that data processing in different components is parallelized. So once we retrieved one URL from the main, we can input it into Kafka. We can make a procession of it, for example, do a plain text transformation or a machine learning extraction, not waiting for whole domain to be completed. And just to illustrate the previous architecture, we will quickly go through life cycle of single request. So on a first, client sends a domain to REST API endpoint. It might be one single domain or several domains, doesn't matter much. Support both batches and single. We generate the request ID, write a status file to our S3 storage, which is used to like a long-term storage for everything. And request is being sent to Kafka to special input spider topic for consumption and processing. So basically, this is this first part. Then spiders come into the picture. So they are consuming the incoming request and start processing of the request, crawling concrete domain, which was given to it in the request. Common crawl part will be explained slightly later, but you might think about it as a cache we use to avoid going into actual domain, but we can retrieve data from common crawl storage. Basically, spider crawling the domain and sending all the documents we retrieve from the domain into Kafka back. So we use Kafka as storage for all HTML documents we have. As crawl is complete, we send event about this into special events topic, which allows us to coordinate different components in the system. Then third component, in parallel to the crawling, as I've said, third component comes into work, starts consuming retrieved HTML from Kafka, applying plain text transformation and writing plain text into another topic, again, into Kafka. So, which allows to parallelize the work for crawling and HTML to text transformation to reduce the actual data availability on S3 for one single domain. Then fourth component called saver is performing consumption of HTML, plain text, and optional machine learning results from Kafka and writing on S3. And once the end of crawl event is received from the topic, we close files and update the status of concrete domain crawl on S3 as complete. So basically, this is the life cycle, how one single domain is processed in the system. But at the same time, every component here is not necessarily one single container running a concrete Python code. It might be like 40 spiders running at the same time. Kafka allows load balancing of incoming messages. So all those spiders will process their own set of messages from the topic, basically load balancing the job. So we have horizontal scalability of every component in the system. And if we have lots of domains to be processed, normally we might have up to several thousand domains to be processed in one short bursts. We can have lots of spiders running concurrently, speeding up the whole process. And very, very quick about common crawl. Common crawl is an open repo of web crawl data. They currently having 3.3 billion URLs from 36 million domains. Yeah, I forgot to add the link. You can Google it. They're providing nice charts about volumes they're providing, and they publishing their snapshots on a monthly basis on S3. So as on S3, you can read this data basically for free, by just paying for the traffic. So it provides like optimization of our expenses, because on average we overlap, like in terms of domains we might need to crawl. About 30% of domains are already present in common crawl. So we don't crawl those domains at all. We just retrieve the data from common crawl. But we've done optimization of the index just to make the lookup faster. So we are basically building inverted index on our S3, which gives us by a domain name, list of and location of URLs in common crawl data. And the quite important part of our system is storage, how we organize it, because at the same time, we want scalability. Millions of domains with billions of URLs should be quite easy accessed by different roles in the company: data scientists, data engineers, DevOps engineers. We want to store everything because you never know when you will need your data. At some point, you might require some weird headers from HTTP server returned. So we store everything. And we want to access data as soon as possible, because basically to train machine learning models, you need to experiment on real data, on large volumes of data. So you might read the same websites over and over again, hundreds of times. So it should be quick process, optimized as possible. And basically, we want to provide 3 different types of access to our data storage. First is a sequential read of all documents crawled from one single domain. Again, second is ability to retrieve individual documents. We know the URL, we want to retrieve it without reading whole data set. And third access we might want to provide is read-only metadata of documents. So when we don't touch HTML data, but might want to get just URLs when they were retrieved, their content type, and other meta information. So to make everything access possible and make them as fast as possible, we do the following. So basically, data is organized in this domain order. We store everything in S3. So blog.scoutb.com becomes com/scoutb/blog. And under this prefix, we store all the data crawled from this domain. In different subfolders, we store different formats. For example, we store HTML, plain text, the machine learning features under this prefix, which allows, if you know the domain, you can really quickly get access to all domain data. For data itself, how to store it, we use common crawl approach. So it is WARC, which is an open format called Web Archive, which is a container format which stores all the headers and all the HTTP responses in a convenient text format. Besides data with ARC data, WARC, we store meta file, which is basically just a JSON line with one URL per line, storing information about the URL. So like its URL, its length, when it was retrieved, content type, and other meta information we need. And in addition, it stores the length and offset in a compressed chunk of a data file. So if we need to retrieve one single document from our storage, even if it's millions of URLs stored for one single domain, we can issue special S3 request asking for specific data range. So S3 supports retrieval not of a full file, but only for some portion of a file. So it becomes much faster because network bandwidth is much lower than disk read access. So yeah, this allows basically to reuse the same format we have in common crawl in our internal format. So a bit of statistics. Basically, we have several installations of our system since March, I think, this year. We have it in production, and we process about 1 million domains, 70 gigabyte, not that large, but we crawling only really few pages, like 3-5 pages per domain to reduce the latency. And we have several in-depth crawls up to 10K pages. They are much larger, and it's in total about 3.1 terabyte of data with 16 terabytes of raw HTML. And this data could be processed on Spark cluster in about 1 hour. So if you really want 170 million URLs to be processed by your machine learning model, you can start Spark cluster and using our libraries, you can just crunch all those texts in 1 hour. And for data access and ML pipelines, it's like really short. We're using Spark for everything on top of Databricks. And we have several levels of data access. We use our own format to store the data from the crawler. We needed to write our own libraries to provide convenient interfaces. So first level is a low level. When you have a full control, you can retrieve any specific request for specific domain in the format you want. You can get every header during the client to server communication during the crawling, and you basically do everything. High level wrappers, when you don't interested in some details, but just want, for example, landing pages for specific set of documents. And the third level, which is very important for data retrieval and data processing during machine learning experimentation, is a specialized Spark utilities, which are automatically adjusting and doing parallelization for data processing according to a cluster configuration. So it's a set of Python libraries which is allowing you to just do really quick experimentation on large data sets without thinking much about low-level Spark details. So key takeaways from my talk: you shouldn't be afraid of writing your own systems. Sometimes perfect solution just doesn't exist. Second, sometimes requirements which look contradictory with specific tools like Kafka might be few-fold together quite good. And yeah, Kafka is amazing thing. If you're not using it, worth checking at least. So yeah, thanks for attention. Have questions? We have 4 minutes.
No worries. Thank you. It was a great talk. Thank you for sharing. So we have one question in the chat in here. Why to convert it to plain text? I have done it that in the past, and I found it's easier to work with, but people talk like I'm crazy. And a second question to that one, and how do you convert that much scraped text to a plain text? Okay, you are muted, Max. Can you unmute? No.
Okay, sorry.
Yeah.
I got lost in Chrome windows. So first question was why we're doing plain text conversion, and that's basically the main motivation is we want to just perform transformations when we know lots of people will be doing over and over again. We wanted to do it only once because the storage is cheap, and we know that lots of our models are using plain text and they don't need raw HTML to deal with. We're doing plain text transformation during the scraping. So, which basically means we do HTML to text transformation only once during the scraping, and then when somebody needs plain text, it just reads it from S3 and not wasting CPU resources. And the second question was, how do you convert? We tried different approaches. If I'm not mistaken, at the moment we have two libraries. One is just text, and second library is, I don't remember I think it's LXML something. I don't remember exactly. We just have lots of libraries in our package, but it's quite fast HTML to plain text transformer, preserving the structure of sentences and a bit of a HTML structure. And another, how do you choose organized Kafka topics with that many crawlers, and which tool for extraction? In principle, we don't have that many topics. So we just have like spider incoming request topic. Second is spider output, which is like contains scraped HTML data. Third topic is plain text output. So plain text converter consumes spider output topic and produces plain text output. And the fourth topic is events, which we use for coordination of everything, like small events when we started to call the domain and when we stopped doing so. So it's just 4 or 5 different topics we need, but every topic will have many partitions, because basically partitions are limiting your parallelization. If you want, for example, 40 spiders, you have to have at least 40 partitions in your incoming topic. For orchestration, we're using Kubernetes, and that's a magic our DevOps are providing. So we just deploying, specifying how many types of a specific container we want, and yeah, it just works. So we have more questions. Please go ahead.
Yeah, there was another question which is a bit up. So there are 3 questions from Matthias.
Okay. How do you manage crawl spiders? Do you manage a job in an own cluster or just using Scraping Hub? No, we're not using Scraping Hub services. We're considering Scraping Hub, but they having like major disadvantage from our perspective because first of all, they're expensive, and they have slightly different concept. So the idea is that you write in your own scraper, which is like taking the HTML, apply transformation on the fly, and produce high-level data you want to extract. So then you upload your code in the cloud, and they just start in the cloud when you want to, and they charge you also these resources. On our side, we more interested in keeping the data from websites in HTML form on our own storage, because we know that we will run over and over again our machine learning models experimenting with data. So we don't want to rescrape the same domains over and over again. But Scraping Hub not providing this usage and this model of scraping, so they running in their own clusters. So to manage spiders, at the moment we just starting fixed amount of workers of a specific kind. Our production cluster currently running 40 spiders. and most of the time they're idle. It's not very efficient. So auto-scaling might be helpful here, but we haven't done it yet. So yeah, I think I answered the question. If you have more questions, you can send me either email or via Zoom. So yeah.
Thank you, Max. Could you please also share some contact details in the chat so then people can join, can write you, and then I will also share in Twitch.
Okay, and I will share my presentation slides, so they will be available.
Okay, cool. Thank you. It will be shared through, I assume, our Meetup account. So feel free to jump in there and then wait for the fantastic email with all the details. Thank you so much, Max. It was really interesting to know some insights, despite the fact that I'm from the same company, but it's always interesting to know more insights. So the next speaker, actually, it is Luben. Would you please turn on your camera and then join? And we are welcoming you with your really interesting talk about metrics for the quality of software engineering process. So stage is yours.
Yes, thanks. Just need to share my screen. All right, I hope you can see my screen now. Perfect. Yes, so welcome to the second talk. As already mentioned, my name is Luben, one of the organizers, metrics for the quality of a software engineering process. So this would be a higher level talk, so it wouldn't go in coding constructs, but hopefully nevertheless interesting. So I want to start with a question, actually. How many people in the room, in this case on the call, have experienced at least one of those problems on a project? I'm assuming most of you, if not all of you, are working in the software industry. And the problems are: development takes way longer than expected, or major bugs escaping to production, or maybe high stress level and team happiness kind of low, or communication in the team or with other teams is not optimal. So I can't see the whole chat, but you can just raise hand if you wish to say, okay, I have seen that somehow. I can talk for myself. I have experienced this in my career as a software engineer and working with different teams. So about me, I run micro software consultancy company since 2017, and consultancy has a lot of disadvantages. If some of you are working as consultants, I think you would agree, but it has also some advantages. One of the advantages is that you get to work with different teams, with a lot of teams. And by working with a lot of teams in different projects, at some point I started to notice that some of the problems that the software teams are facing do not necessarily lie in the code, in the technology. So some of the problems are a bit on a different level. And I think we could summarize them in three big points. So what are the challenges that software teams are facing? I think it boils down often to that the teams want to deliver faster software to their clients, or they want to experiment more, to do more experimentation. And this falls under speed. So I call it, the team wants to be fast in what it's doing. And it's also connected directly to resources, to money, right? Because it makes a difference if you deliver something for 6 months or 12 months. And it has also some connection with predictability, because maybe you don't have actually a problem with speed, maybe you're fast, but you misjudged how long it would take. And from the start, it's not that you're slow, it's just your prediction was not correct. But I put all this behind the label speed. Another dimension where there are challenges is quality. So teams usually would want to have less bugs on production. So there's the quality. And another one, I think, is happiness, team happiness. Stress levels. People don't like stress. Some amount of stress is tolerable, but at some point it's not fun anymore. So team happiness is definitely another dimension in which the team can strive to improve, I believe. And we can put those things in a triangle. Let's put it like that. We have speed, we have quality, and we have team happiness. And now the question I want to raise is it possible that you could improve in all dimensions, or there actually there is a trade-off between them? So is it possible that the software engineering team is delivering a lot of features with high quality, with few bugs, and it's happy, or it's actually impossible because if you're very quick and you're very happy, probably you don't spend time in testing, and then your quality is low. And should you compromise there? And the main claim that I would want to make in this talk is that you actually don't have to compromise. So there shouldn't be a compromise here. It is possible, it's what I claim at least, to have quick development, to have high quality and have relatively high team happiness. And it could be the other way around as well. So you could have unhappy team, your quality could be bad, that you have a lot of problems with your code, and you're actually slow in doing this. So how can we go into achieving that? I think it's a very difficult and challenging question to answer, but I think a step in the right direction is to think about the software engineering process the team is using, and not any software engineering process. It should be a good software engineering process if we want to improve in all these dimensions. And now it comes the question, what actually means good software engineering process? What is good and what is bad, and how we can differentiate between those? And this is where metrics come along. So you can't, if you can't measure it, you cannot improve it. I'm sure many of you have heard of this phrase. It has been attributed to different people throughout history, and it makes sense, right? So we need some way of saying, okay, this is better than that. And this is the main topic of this talk, to have some, to present measurable metrics for a software engineering process. We developed this set of metrics in my company, and we use it to evaluate the engineering process of clients. So yeah, without further ado, here are the metrics. They go in different directions, but the common thing is that they are measurable. So you can put a real number behind every metric, and you can measure, use them with your teams, for example, to see what you get as numbers. So the first place I would think it makes sense to look into are the code reviews. Code reviews are great because they're a log of how the software is getting developed, and you can look deeper into that and maybe have some insights. What could you measure there? We can measure some, for example, the days a pull request stays open, right? It makes a difference if it usually the pull request stays open for 1 day, for 3 days, or for 2 weeks. We can measure the days for the first command to arrive on a pull request. But we can also measure other things. For example, how many of the pull requests have a good title and an explainable summary, so it's easy to understand. We can measure this as a percentage of all pull requests. How many people from the team actually do the code reviews? This good can give insights of the team dynamics. And behind all metrics, I wouldn't go too deep in every metric because we wouldn't have the time for that. But they somehow connect to these 3 dimensions: speed, quality, and team happiness. Right. So going forward, we can look also into the development process. if we are talking about speed, this means the engineering team needs to produce software at the end of the day. And maybe we can look in how many uninterrupted hours per day a developer has for coding, or the days it takes to configure the development environment for a new developer. So if we want to be quick, in the software industry, in teams, new joiners come, some other colleagues change teams. This is completely normal. And this time, for how long does it take for a new joiner, new engineer to become productive, plays also a role on your velocity overall. Another metric could be the days it takes for a new developer to become productive. To become productive, this takes probably longer periods of time, because the person needs to get to know the development environment, the software architecture, the business domain. This is a longer process, but we can also measure how long does it take to actually merge the first pull request. Is it a few weeks or a few months? So this could say something on itself as well. Another thing we could measure are the days when we have a ready release of our software. How long does it take actually to put it on production in front of our clients? Is it just a few minutes, few hours, or maybe there is a complex process there and it needs a few days? All right, so moving forward to testing and quality. Here are some metrics we can use to measure that. For example, time it takes to build the code without tests. So if we want to have quick feedback about our system, it will be useful if we can execute the tests quickly. We can also have a slower test that run much longer, but it would be good to have an option to execute quick some sort of test. Code coverage is a very popular metric. By the way, I should say, none of all these metrics that I mentioned, they don't make much sense by themselves in isolation. So if you look only in one metric, probably it wouldn't say so much about your engineering process. But hopefully, if you look in on all of these metrics for your team, maybe then you have a fuller picture and you can spot where there are areas which could be improved. And the same with code coverage. The fact that you have high code coverage doesn't mean that your engineering process is necessarily the best one. You still might have problems. But if you have very low code coverage and you have problem with quality, well, maybe this explains something and you could look into that. But you can measure also other things, like, for example, you can just count the number of occurrences when a major bug escaped to production in the last 6 months. Or you can count the number of bugs produced per sprint if you have the discipline to actually document that in your system. If you use Jira, for example, you can document that relatively easy. And you can also measure the number of failed builds because of flaky tests. So I find this interesting. So what does flaky test mean? A flaky test is a test which fails not because there is a problem in the code, but because the test is written in a bad manner. Often examples for those kind of tests are integration tests, where you have some state in the database and you don't write the tests in a good way, so they are somehow connecting on each other, or you have race conditions, or you have problems with your infrastructure for running the test, like resource problems with Jenkins or something like that. And this is bad. This is quite bad because it defeats the point of having a test suite. So when your build is red, you don't know anymore, is there actually a problem with the code, or it's just our flaky tests? And then you wouldn't trust anymore actually your tests. So it would be good to keep an eye on that, and you can actually count how many builds are failing because of that. If we go to velocity and predictability, what we could measure there? Well, we could measure the discrepancy between what we commit and what we achieve per sprint in percentage. So again, probably you're using different systems, but in Jira you have velocity charts where you can see easily what has been achieved, what was being committed, and you can get a median. By the way, the metrics that you can measure, it's good to get the medians and not averages, because you have outliers sometimes. So you have things that are will not be representative for your process. But if you take the median, hopefully you get the outliers out of the picture. You can measure also discrepancy between higher level milestones you have and reality, what you achieve actually in the team in the, let's say, last 6 months or last 12 months. So you have this on a lower level, on sprint level, you can see the discrepancy, but you have also on higher level the discrepancy in the milestones that you want to achieve. You could also measure the number of developers that you have on the team. There's these 2 pizzas saying that if you can't feed the team with 2 pizzas, probably the team is too big and there are inefficiencies. And you could also look into the fluctuation of developers in the team. I find this quite interesting. So we came up with a formula for this. The number of the developers who have left the team divided by the number of developers who are in the team as of right now. And you can take a time period like last 12 months. So if this number is very high, this means a lot of developers have come to the team, but also left the team. And why would be this bad for your velocity? As said before, I believe that for an engineer to become productive, there is a good amount of time that he needs to get used to the engineering process, the environment, the business domain, and so on. So if people are constantly fluctuating in the team, probably you cannot get the efficiency. All right, so I think, so those were all of the metrics I wanted to present to you. Yes, the one more note, I think when you want to improve engineering process, you need to have a holistic approach. You need, it would be not a good idea to really concentrate on one metric and say, okay, we want to merge very quickly our pull requests, and then you realize, okay, but then we are not doing a real code review and our quality metrics are going down. So it's a challenging topic, I believe, for companies and for teams, but you need to have a holistic approach to look from different angles on the whole problem. Yes, so this was my talk. Thank you a lot for the attention. I think we have quite some time, so happy to answer any questions.
So do we have any questions? I don't see anything in the chat, but I saw people raising hands as a feedback on your question if they suffered through this.
Oh yeah, that's great. So this means some people have experience or the talk relates to someone. Glad to hear it.
Yeah, it was a great talk.
Thanks. This is the first time I'm giving the talk, so I would be happy to hear your feedback.
Maybe anyone would like to unmute themselves and just give the feedback. Oh, I can see very interesting and good presentation from one of the participants.
Thanks.
Cool.
Well, all right. If you have any questions, feel free to reach out. Yeah, it's a big topic, so probably it's not very easy to come up just with some question out of the blue.
Yeah, it's a sensitive topic.
Yeah.
Okay,
Thanks
cool. Thank you so much. Thank you for sharing your insights. Oh, we have somebody unmuting. Would you like to ask the question?
Yes, hi, I'm Flaminia, and we know each other with Luben. We work
Hi,
together.
Flaminia.
So great talk. I have a question. If you might suggest to me something to improve the speed of a team, because it's anyway a relative concept, because it depends very much how much this team is committing to. Maybe it's just too much what they think they can finish in a sprint, and that's why the percentage of tickets finished is not so high. Or do you think it's an absolute problem?
Yes, exactly. It's as you say, it's difficult to measure, because what means fast and what means slow. It might be that the team just overestimates what it can achieve, and then it will be always slow by definition, right? Because
Yeah.
just cannot estimate good enough. By the way, problems with estimations are totally okay. It's very difficult to estimate software things. So therefore, I think the first step is to find where the problem is actually. So, and therefore is this list of metrics. So I believe this is this was the idea actually behind creating this list of metrics, to do a benchmark of the team and hopefully see, okay, what are the metrics now, right? And then you can have a conversation which is more meaningful, because you have concrete numbers behind every single metric, right? And you can see, okay, we can concentrate on this one or this one. Do you think this is a problem or that is a problem? And then you can act, you can do something, and you can say, okay, now we will change this, and we will evaluate again after 1 month or 2 months and see if these metrics change somehow. So the first thing I would say is to actually, get a set of somehow of things that you could measure to say where you're standing at the moment. Yeah. Does this make sense?
Yes, thank you. It's anyway a complex question, and maybe you don't have now all the background, but thank you. It's very interesting for me. I will look through your presentation again and think about that.
Yeah, exactly. The main point is the thing that you say, background. So you need the background to understand what the problem is. And to have the background, you need to evaluate your engineering process from different areas, and then as a team find out what you actually want to improve, try to improve it, and then measure again and see if this has been improved or not.
Right. I have just last comment on that. I have the feeling that if a team can see at the end of the sprint all the tickets transition to done, this would be already a very good sign of rewarding and probably will increase the team happiness. While seeing all those open tickets, in my opinion, it's really not the best psychologically. Yeah, thank you very much.
No problem at all.
Thank you, Luben. It was great to learn more insights from you. Thank you. We have an interesting announcement from Christian. Are you here? Awesome, but you're still muted. Can you?
Now I think that you can hear me.
Yes.
Cool, but I think that you cannot see me, but it's totally fine. Maybe now you can see me. Cool. So if you can see my screen now, I just wanted to let you know that the PyCon US call for papers is open. If you don't know about the PyCon US, some people call it the big PyCon, or I don't know, the first PyCon, I don't know how you want to call it, but it's of course the PyCon that is happening in the United States. This year, a difference compared to the previous year, it's happening in person in a more like an hybrid approach. There will be a live streaming, but we are all crossing our fingers to have it in person now. It will be in Salt Lake City. If you don't know where Salt Lake City is there on the west of the United States. The city is quite beautiful. I didn't know it myself, so I was just checking some pictures, and it really seems like a promising place to have it. And I just wanted to let you know a couple of things about the conference. The most important things are the dates. I mean, the conference itself is happening from April 29th to the May the 1st. There will be, as always, sprints, tutorials, there is a job fair and everything. The important timeline here is that the call for papers will close on December 20th. Then in 1 month afterwards, there will be all the emails about the acceptance or not. Really important thing. There are some sponsorship for people that submit talks and they cannot fully cover the trip to the PyCon US. So if you, for example, you're struggling a little bit, maybe you can pay a little bit of your trip and you can rely on those financial helps to help you to cover a little bit the plane tickets or maybe the hotel and so on and so forth. Something really important is that when you submit your talk, there is also a mentorship program. If you're really new to submitting talks, you can get help from people. And I'm not sure at the moment if we have anyone in the audience that speaks Spanish, but I'm also a co-chair of the PyCon Charlas, which is a specific track of PyCon US, that is in Spanish. So if you're also speak Spanish and you would like to submit a talk, this is, I think, the 5th or 6th year that this is happening. It's a whole track, mainly focused on Spanish-speaking people. And as you can see in many parts of the website, you can see the English part and also the Spanish version of things. So yeah, I mean, the information is there. You can go to uspycon.org/2022 and you can find all the information. We still have a couple of days, well, more than a couple of days to submit a talk. So yeah, if you have any questions, you can reach me out on the chat or after the event. And that will be it.
Thank you.
Thanks to you.
So I'm handing over to another host who can introduce me as a speaker. Or maybe not. Okay, I'm an adult. I can introduce myself.
Yeah, I can do that. I can do that. Just give me a second. Yeah, I'll do it freestyle. So Anastasiia is making really a lot for this meetup to happen. She has been with the meetup, correct me if I'm wrong, Anastasiia, from the very beginning. We will now have her talk, which is make your software architecture shine with domain-driven design. So yes, Anastasiia, the stage is yours.
Thank you, Luben. So I'm going to share my screen, the empty screen, and then the slides will automatically appear in there. But this screen sharing is super tricky when you use the notes from Mac. So I need some input. Do you see the slides?
Yeah.
Okay, perfect. So in this talk, I will be moving around with the Miro board and also the slides. And if it's too small and you don't see everything, please let me know. Just shout if you don't see it. So today is a talk about domain-driven design. A few words about the speaker, me. I'm a lead developer at Scalable in Berlin. And as Luben already mentioned, an organizer of PyBerlin. I have 11 years of experience in software development. And from those 11 years, 7 years are in Python. I'm super happy with this community and also sharing my experience, learning from others, just fantastic. And I still love Python. This is my preferred language. I used to be a C++ developer, but then since transition happened, I just decided to stay in Python. Well, maybe one day I will be learning another language, but still Python would be always in my heart. And today is not about me. Today is about you, your architectures, and how domain-driven design can help you. So I really expected this event to be offline and prepared a lot of questions from the audience to learn from you first, and then to get more into details. So please bear with me and then write all your comments into the chat. I'm going to read that out loud at the end of the talk. I really want to learn your backgrounds. So I'm curious first, what is the good architecture? What do you think? I'm going to give you a few seconds to write in the chat something. Maybe if there is something somebody can chat out loud. No? Okay. So what is a good architecture? Maybe this one, maybe a monolithic one. It's easy to implement. It's like a big shark. It's going to conquer the world and will eat the small sharks. Or maybe something more lightweight and some kind of small services. I don't know yet. So maybe microservices would be a good approach, like the big, the monolith, and then the small ones, decoupled services. Well, microservices is not always a good idea, but why not? It could be great, right? But they should be decoupled. There should not be a spaghetti in there. So how to make the architecture not just good, but great? You can also write in the comments. I'm curious about what you think about the great architecture. I'm going to ask a lot of questions, so just write something in the chat. I'm going to read that later. And if you were thinking about low coupling and high cohesion, that's a good one. I really like that one. If you are not familiar with those words, so the cohesion is about how well the components, the elements within one module belong together and then serve one common big goal, one common purpose. And then the coupling is a bit different thing. That's about how many interactions and how the components, the modules are interacting with each other. So on the left side, you can see the low cohesion. That means that the components are not serving the common purpose so well. And because of that, they need to have a lot of interaction. So there is also high coupling. On the right-hand side, you can see something better. You can see highly cohesive components, which are serving one single goal. And then the low coupling just comes hand in hand with that. Looks really nice. But the key question is how to achieve this perfect state of architecture. Just how? When I heard those words, then I was not quite sure. I mean, yeah, it's really nice to decouple and then to make those systems work independently on their own goals, but how to decouple that? And here comes the domain-driven design. So the question to you again in the comments, please comment that. How do you, if you know anything about domain-driven design, just anything in general, the name or how it works or anything that you can use. I can see a few comments. Okay, another question would be, do you use domain-driven design? It's interesting because you might know the concept, you might know why is it useful, but you might never use it. As I used to be like that. I knew that it exists. The book was like huge, it's really big, and I didn't have enough motivation to read it, to be honest. Really honest answer at this point. And I didn't know how to use it in my own projects. I didn't think that when I'm creating architecture for one feature, when I'm just developing one feature, it's useful enough, but it could be useful for redesign, for restructuring, for also some feature development. It depends what size of the feature is that, and also what kind of project is that. So let's start with something. I'm going to start with the quote of myself. There is no magic, and the domain-driven design is super simple. Domain-driven design lets us to identify domains and make a very nice split as a foundation for a future architecture or just a new architecture. What is the domain, you might ask? Because it's a ground for domain-driven design. You need to understand what domain is. It's actually a business word which can mean a lot of things, but that word, the domain specifically, means summarizes the problem of the business that this domain solves. So this could typically involve the rules, the processes, existing systems that need to be integrated as a part of the working huge system as a solution. So the domain is a set of ideas, knowledge, principles, data, services, everything around to solve one problem. As we mentioned before, in the low cohesion and high cohesion and low coupling, as we mentioned before, the more you decouple and then the more you define the domain specifically to solve one goal, the better architecture is. So domain-driven design can help with this problem. I'm going to tell you a story about how to develop a project which is completely made up. I never did that in my life, and it's not related to any work that I do at work or in my personal time, but it's a nice project. So it was summer. I was sitting at home. It was like 30-something degrees or maybe 20. But you know what? I was thinking about ice cream. So I came up with the idea of the ice cream shop. It's called Ice Cream Now. So that's the idea of the project that we're going through right now. We would have a few steps on the way to explore this project, to learn about the ecosystem of it, and then think how it's supposed to work. So first, this is like a small project definition. The name of the project, Ice Cream Now, and then who we're building this for. We are building this project for people who love ice cream and they want it to be delivered as soon as possible to their home or maybe to pick that up. So what are we exactly making? We're making a delivery application or maybe a platform, a website, a mobile application where every user would be able to order the ice cream. And this ice cream would be delivered to their addresses, or they can also book something for the pickup in the store. So let's start. I'm going to show you my report. So this is the my report. This is some domain-driven design stuff, fancy stuff. I really loved it. It took some time to prepare this presentation. And I will share this my report, the PDF of it, in the end. So you can also go through all the learning steps and then you can read more about it. So the example, how would you start? First, I would start personally with the definition. Oh, I can see the comments, component-based. That was about the good architecture. The one that makes changing things easy. That's a good architecture. You're right. That was Luben. Then Kapil said component-based architecture. Yeah, that's also right. And we're going to decouple the components today. Okay, cool. So the example, getting back to the example. This is an example of event storming. This is a tool, well, not the tool that we used to as a developers, but this is the way of presenting the user actions. So all of the orange sticky notes, they're events, domain events. So this is like a huge domain of the entire project. This is the only one domain, the project, which is Ice Cream Now. And those small sticky notes, they're all different events. The trick is here that we are not putting the events in a super programmatic way. This is all more like systems thinking. We're thinking about the product, how it's supposed to work, what is the user journey, what are all the actors doing in here, but also the systems. There are also different external systems, policies, comments, actions, a lot of things. To simplify this, I put only the domain events, the actors themselves, and some external systems, which were obvious enough to put. So let's start. You remember we have our ice cream shop. And then as a user, I would go outside, I would feel it's super hot, and then I would want to buy ice cream, like eat it now. And then I would see some ads on somewhere. I would scan the code, install the application, register a new user, myself as a new user, then turn on the location services because I need to locate the nearest shops. And then I will enter the location, check available ice cream shops, choose the favorite ice cream flavor. And here starts the fun because there is an external system which is coming into play only in one particular case. When I want this to be delivered to my address, I need to pay first. And if I want to pick up, I don't need to put any extra data. I just can book in the store and then go there. Of course, this could be way more detailed. As I said before, this is just an example, and there's no need to put all the things in super detailed way in there for me right now, but it could be also different. So this was defined by me because this was the project that I presented, and this is how I see this project. If the project has a bit different ideas, for example, the registration of the store of the ice creams is different. So this would be a different actor. The local store manager would register on the platform to suggest to sell some ice creams. And it could be all different. For this example, it is as it is. And the trick after this, when we define this, which is connected to each other, this path is a bit separate because it doesn't connect to any of those. This is a separate registration of the local store, and it could be many stores, and they could have different ways of registering. But the thing is that this event storming is supposed to show the full big picture from the beginning to the end. So from the idea that user needs this product, that they need to use this platform, they need to do something, until the finish line when the user is happy, they're giving some feedbacks, recommendations, or anything else. It could have also many more things on the top, like some logistics, tracking, insights, maybe some managing, administration for the local store managers. You can add anything that you like. As a next step would be domain definition. So we would jump to this part. This is how I define the domains. Of course, you can do it in a different way. As you can see, these are the small ones, and there is a big one. It could be also split into a few. Depending on the heuristics that you used, the split of the domains would be different. And it's pretty subjective to which one you have chosen. You can try different things. And then on the next steps, you can see the difference between the messages that all the different domains are sending to each other. For example, in this case, I picked the user sign up, shop sign up, ice cream discovery, order processing, so everything which is related to the order processing, and also the reviews. Those are the domains which I defined. And as a next step, to discover and to research more the way how they interact with each other, I would go and model the messages between systems. So I would put the domain in here, the bounded context, which is a domain I defined, and then the user, some actor. It could be just a user, it could be local shop, then the application, that's the web UI, and then the messages which are sent from the user to the context and then back from the context to the user. You can see more in details what kind of messages are there. You can model all the use cases. This is not one single huge use case, those are different ones. And after that, you can also take some time to start modeling architecture, which could be tricky and hard. And I'm not gonna go into details as I have just 20 minutes in total for this talk. And this would be maybe a few days brainstorming with the entire team, not only developers, but also stakeholders, designers, so everyone who can contribute in this knowledge field, and plus tech leads, directors. So the C4 model has different levels. The first level is like super high level. We have the application. I'm not showing you that in detail on purpose. So it has the entire application, then the user, the actor, and then external systems, and then the messages between them. You remember the messages before, the messages here, so you can kind of correlate and then use the previous steps to combine something together, because you already learned about the project more than you had at the beginning. So then after you pass the first level, on the super high level, you go more into details. So you zoom in on this specific part, which would be the entire system that you're modeling. And after you zoom in and define what kind of components it has, you would zoom in more into details. And probably here in the components, you would see those domains as the separate components. You can also split them more. But then on the last final part, it will go super into details. So you like zoom in into one component and then you define the different either classes or subcomponents. So it depends how you build it. Or maybe even each component would be its own service. And then you define the services inside. So you can also learn about the C4 model more in detail. You can also check the examples on their website, how it looks. And actually, I would like also to suggest a few books. So this was my example, and yes, you should see further reading suggestions. I would really recommend you to go more into details into domain-driven design book. Learn from it. It's really big, yes, but if you go into their website, there is a sort of help how to read the book in a short way. On the diagonal reading, and then it goes really well with the team topology. So after you define the domains, you can also define how many people are needed for working on those domains, what kind of interactions do you need to build between those teams, do they need to be stream-aligned teams, enabling teams, do they need to collaborate with each other? So those are more like contracts between the teams, interactions between the teams, and also the size of the team matters, because if you don't put the teams correctly, then you will not get the product that you expect to get. And to learn more insights about all the metrics, about high-performing technologies, all the statistics and how to improve that, I suggest you to read Accelerate book. So this was all for today. And I would really like to hear back from you about the feedback, about the talk, what did you like? And also, I think we have a few minutes for questions.
Yes, thanks for the great talk, Anastasiia. So now, yeah, if you have questions, you can write it in the chat or unmute yourself. We have already one. Can you recommend a tool for domain-driven design, or just using sketch tools?
Well, there are different tools. You can use Visual Paradigm. It's not free, but it's really big. You can also collaborate. There are lots of diagrams in there, basically all diagrams that you might use. You can use PlantUML to build all the C4 models. But at the same time, if it's easier for your team to contribute on the virtual board, just take Miro or any other virtual board, throw the stickies on it, and then just move them around, or otherwise pick one of the tools where you can really contribute. So yeah, sketching also works. Even paper in real life.
I have a question as well. What do you think are the challenges of this approach? So, for example, if you stay too much higher level, maybe you don't have technical specifications, but if you go too much into detail, isn't it too complex if you have too many sticky notes and you lose yourself somehow, or it's not a real problem?
Well, with the event storming, you just don't go too much into details. It's all high level, so you're not defining any services or server providers or anything like this. You're not even putting that the data is being recorded into the database. So those are more like human readable events. Everyone with no programming knowledge can read those. Yes, if you go into details on the architecture on the C4 model, that's why I would not recommend to go to the code level. Maybe on different teams, it does make sense, but if you go super in detail and you have the entire team, like everyone, 50 people, they call, I don't think that this is super productive. So maybe just a few steps in the C4 model, maybe like 1, 2, 3, and then you can split up into breakout rooms or different Miro boards and then do the modeling. If you try to do all the messages between all the contacts, it's a lot. So you can skip that part as well. You can also explore the project's ecosystem in the different ways. There are different tools. I suggest you to attend the workshop from the Ruth Malan. They're really cool. I just recently attended and I learned so much. There are like 1 million tools. By tools, I mean different types of diagrams, learnings about the ecosystem of the project. And it could be like the entire Miro board filled with all the diagrams, but that does help to learn and share understanding. I hope that answers the question.
Yes, thanks. What was the workshop you recommended?
I can write in the chat. It's Ruth Malan. I think it's called Systems Thinking, but they have the entire module of different workshops, a lot of them. I can see another question. Do you think the domain-driven design is enough or something there is missing, in your opinion, to properly design software? Well, it always goes hand in hand with something else. If you just use domain-driven design, then how would you define the teams? Well, I attended different workshops last year and this year. And the workshop, which was the first one about domain-driven design, was about plus team topology. So those two, they just go really hand in hand together. First, you define the domains, and then like you split the services, and then you define the teams working on those services. As for architecture, maybe not enough. So domain-driven design gives you the tool opportunity to do the split. And then how you define those services specifically already based on the domains, that's something else. That's a different tool for that. Also, you need to have some skills in architecting in general.
All right, great. Thanks a lot. If there are no more questions, maybe we can move to the second talk, to the next talk, sorry. Yes, so thanks a lot, Anastasiia. The next talk would be from Python to product and will be presented by Shreya. So Shreya, the stage is yours.
Thank you, Luben. Yeah, I will share my screen and then we can start with the final talk for the day. So hello, everyone. My name is Shreya Agrawal. I am currently working as a product manager at Tier Mobility, Tier Scooters. And I recently started this role. And in this talk, I want to talk about my journey of transitioning from a tech role to into product management. Before going into the talk, a little bit about myself. Like I mentioned, I'm working as a product manager at Tier. Before that, I was working as a data scientist at FreeNow or MyTaxi in Berlin. And I also worked a couple of years as a developer. So I have some experience as a developer, then as a data scientist. And then I felt that I want to move into the more strategic and product side of things. For my education, I studied computer science and really enjoyed it, but then transitioned into data science or machine learning side of things, and then now into product management. What motivated me to move into product management? I think after years of staying in tech and coding day in and day night in Python mostly, I felt that I wanted to move to strategy and product and understanding what we need to create or build next. And also I wanted to experience being on the other side of the spectrum and experience the chaos firsthand. Apart from that, what are my interests? I am very interested in promoting women in STEM, women in tech, and other diversity initiatives. And finally, my journey with PyBerlin has been a very eventful and interesting one over the last more than 1 year, with Anastasiia, Luben, and some other organizers who were part of this. And very happy to be part of this community, of this family, where we share and learn about Python, and also about, like we saw today, so many other diverse topics about Kafka and software engineering and domain-driven development, and so many interesting topics in general. So with that, let us move into the topic for the evening. And the first topic that I would like to talk about is why or how understanding data has benefited me in my journey as a product manager. And this is very specific to my experiences, not a generalized one. So if some things don't agree with you, then please take it with a pinch of salt. And you can, of course, let me know and we can have a discussion about it. But I think, and I'll be discussing all these points individually, things that really worked, that I really find interesting in moving from a career in data science to now in product management is how, as a data scientist, I used to be more focused about understanding the customers or understanding what their needs are, how can their experience be optimized, or how can we segregate our customers, classify or segment our customers so that we can understand them better. And then based on that understanding of our customers, we would create data-driven products around that, or just use that information in analysis and building the next product or next platform. And that, I think, is my first key point here, that as a data scientist, one of my key roles used to be understanding our customers, creating dashboards or analyzing them, and also using, creating segments around the customers, understanding customer profiles, and then how do these customers respond to different marketing strategies that we are trying to implement. And all this information, when I have now moved on to the other side of things, to the product side of things, I know how these things work, and what is the capacity or the capability of which we can stretch the algorithms or implement the algorithms to understand our customers, what kind of segments can be created. And I can understand the the spectrum of this better, I feel. And that helps me understand my customers and create products for them better. Also, I think a main part of product management, especially the ones if we are creating a product that is very consumer facing, is A/B testing. And A/B testing is something that is supported by the data science, the data analysts, and the entire data team in different ways. And having that, having created those A/B tests from the scratch in the first place, definitely helps me understand what is the need for having more homogeneous splits in the data, what is and how long should we have the duration, etc. So yes, my first point being understanding the customers better. And then moving on to the second point would be making better product decisions. I think one of the key metrics or key tasks of a product manager is understanding how well or how bad as well sometimes the product is doing, and we need success metrics for that. And having an understanding of how metrics work, what are the loopholes in that, can really be useful in creating those success metrics. And when I was working with Python or pandas, I had a first-hand experience of what is the capability or what kind of data is required. Is the data noisy, or is it clean enough? Do we have the pipelines in place or not? So all that information was quite useful in creating the KPIs. But now, I am more responsible for deciding what those KPIs will be. And I personally feel that having created those KPIs in the first place is definitely helpful in deciding what the success metrics would be. Also in product refinement, so you create the first iteration of the product, you see how good it is it useful for the customers or not, is it having a good market penetration or not. And with that information and that information is available to you in terms of data, in terms of CSV files sometimes, and you have to crunch that data to move into the second iteration or refine the product and make it more useful for the customers. And having that data background definitely is very useful in understanding how the product is working. Next would be product managers have to work very closely with the data team and the tech team, and a lot of teams in general. So having that understanding of how the tech team actually works helps you connect with the developers and the data scientists, analysts, and all those wonderful people who help you create those products better. You can understand their challenges, and you can understand what are the shortcomings and how you can help them better in going forward with their tasks. And the data and the teams are also able to trust you more when you come with that kind of an experience, because they know that it is not just intuition, which is very good to have, no doubt, in the first place, but that intuition is backed by data, backed by information and statistics, and the communication is more effective and productive in general. And it also helps you, going to the fourth point, it also helps to optimize the time when you're working, especially with cross-functional teams. And also one thing that really struck me, I read it somewhere, that every time you choose to work on something, it also means that you are choosing not to work on something. So you have to really prioritize on, with the limited time you have, limited resources, and the limited people that you have in your team. You have to prioritize what to work on and what to not work on, and also think about how you can think in the future the product will look like. And having that understanding by working in a tech environment or in a development environment in the past can definitely help you provide better estimates on what is feasible and what is not feasible in the time frame you're expected to deliver that product. And also when you're working with cross-functional teams, many a times, a lot of your time is gone in just bringing everyone to the same page. And of course, not everyone can be happy, but having an understanding of where they are coming from, the challenges that they have been facing, definitely helps you connect with them better. And even they can connect with you more. So you develop a better synergy, a better sync with them. And finally, continuing on to the stakeholder topic and aligning with product teams, everything sounds good when backed with data and not just plain intuition. So when you are talking to the stakeholders or even in aligning with your internal teams, it is very good. You come up with a very strong backing if you are backed with data and information. And also the tech teams will be able to help you out more if you speak their language and connect with them better. So this was about how I feel till now in the few weeks or months that I have been as a product manager, how my background as a data scientist or as a tech developer has helped me move on with this role. And there's this one interesting question that was raised to me by somebody, that do tech skills benefit a product manager? Rather, the question works, are tech skills necessary for a product manager? And I think it's a very, it's a fine threshold. I don't think it's necessary, but it is a good to have. And there are both pros and cons about it. And in this next couple of minutes, I just wanted to quickly touch base on what I feel are the pros and also the cons of having a tech background and then moving into product management. No doubt it can be done without it as well. And there are many great product managers who are doing amazing things without having firsthand experience in tech. But coming from my experience, I feel that it is good to have a little bit of experience in tech firsthand. I think, like I was mentioning previously as well, that you find it easier to define what is needed in terms that a dev team can easily understand if you've actually worked in the dev team in the past. Second point would be you can discuss the scope, knowing what may have a bigger impact on effort. So, when you are working in a tech team, sometimes, things that would work on one computer, one system just refuses to work on another. And we have this silly joke that we should restart the computer in that case. But jokes apart, that always doesn't work. And having that experience that what works and what does not work gives you a better understanding and gives you a leverage to understand what are the challenges of the dev team, and also have that backup or that time in hand so that when unexpected problems come in, you can handle them. Of course, not every time it is possible, and development is not a bed of roses. There are challenges, definitely, but you can sync with the teams better if you've been in their shoes at some point of time. And then finally, I feel that you can build relationships faster with the teams. It is easier to speak the same language and understand how to transmit ideas in a way that will compel engineers. It is very important for the tech team, development team, to trust and be motivated in what they are doing. Of course, they can plainly be working on something as well, but if they are enthusiastic about what they are doing, the energy and the productivity will be way higher. So on that front, I think if we've worked in the past as a developer, this definitely helps building relationships faster with the teams. On the cons side, I think of course, this was something that I was wondering, that when I was strengthening my tech or development skills, I wasn't developing some of the skills that are actually needed for product management. And while people are gaining experience in this field, I was gaining experience in the more tech or hands-on sides of things. This could be one point. I personally feel that it was a very good experience that I had, but some people can feel that maybe that's not the best usage of time, and I could probably be using it more on, or one can probably be using it more on developing their product management skills. The second point being that how much technical knowledge is necessary. It's where do you draw that line between now I have enough technical knowledge and now I can move into product management or something of that sort, if you're really wanting to find that threshold. Personally, I've been a developer for many years now, and I still feel that, how much does someone need to know enough about software development to reap some benefits on the product side of things? There is no fine threshold. But as long as you feel comfortable and you enjoy the work that you are doing, that is the best reason to stay in whichever role you are. And that threshold, as long as you are interested in it, you can definitely learn things on the go. And it is not a Herculean task, but more of a topic of how passionate you are about it. And that, as long as you have that, it definitely works. So this was my take on how my experience in the tech field has prepared me a little bit, or maybe more, for the field of product management. And then quickly, I would like to do a use case of Spotify. I think personally, it's one of my favorite apps and something that I really like to use. And from a product perspective as well, I think it is one of the stronger products out there that has made a name and space for itself in the past. And the next 5 minutes, maybe, I would like to talk about how or why I like Spotify so much from a data product perspective. So some numbers to crunch. Spotify has right now approximately 365 million active users with 165 million paid subscribers. That is almost 50% of their subscribers are actually paid, which is a huge, huge number, huge percentage when compared to other brands such as Apple Music, Amazon Music, YouTube, etc. Most of the time, people want to use such platforms, but they do not really want to have a paid subscription. But I think Spotify stands for itself, and the numbers speak for themselves of how strong they have created their presence in the market. Also, one has to keep in mind that when Spotify was launched in 2008, it did not have a standing brand value as compared to when Apple Music or Amazon Music, when they launched their own products, they already have a sitting user base of a lot of user base. I started reading the comments. Maybe I should do that afterwards. Yeah, but Spotify did not have that brand backing when it started. And that, I feel, makes its journey so much more unique. So what exactly, how does Spotify actually function in the product or in the consumer side of things? So Spotify has two sides of things. There are one set of people who are creating music or podcasts, etc. And then there are another side of things, another side of consumers who are consuming that content, that music, podcasts, etc. And Spotify is a platform or is a product for both of these group of consumers. So we will talk about them individually. For content creators, I think Spotify has become such a great platform to showcase their talent. And it is a platform not just for the famous and the most successful singers or podcast professionals out there, but it is a platform for everyone who has talent and has the willpower to create music and wants a platform to express themselves. And one can see the journey that so many musicians have had on Spotify, from being less known to now having very established and successful careers. And I wouldn't say that Spotify is the only reason for that. Of course, their own talent and their own hard work comes first, but Spotify or platforms like Spotify, YouTube provides a platform for these content creators to express themselves. And in that way, Spotify is supporting small artists and bonding with the big artists, because big artists definitely have already a user base, a fan base, but the small artists are the one who need support, and Spotify does it beautifully, I feel. On the other side, we also have Spotify being used by content consumers, people like me who like to listen to music. And I think some of the interesting features that Spotify brings about is so unique. The first one being Spotify is present everywhere. It breaks the conventional boundaries of cross-platform connectivity, and it has a huge set of device support such as Amazon Echo, speakers, laptop, desktop, TV, etc. And any tool or any platform, any gadget that you have at home, you can install Spotify on it and use it. That provides cross-platform connectivity. Your history is saved, your recommendations are saved, and you enjoy music on the go. And also Spotify is not just about, playing music or listening to your most favorite singer or artist. It is about discovery, curation, and social interaction too. Personally, they have this Discover Weekly that pops up every Monday, and I absolutely love it. The recommendations are so good that I sometimes feel that Spotify knows my music taste sometimes better than myself. And in that way, I'm not just listening to what I'm used to, but I'm also discovering new artists and new singers who end up being on my favorite list, and understanding new music in general across boundaries, across countries, across cultures. And that I find is very interesting. And the recommendation engine, personally, I feel is one of the very good ones out there, and I really enjoy it using it. Also, as a consumer, I do not always have to think about what music to listen. I use Spotify mostly for listening to music for long hours during work, and it recommends music in the genre I like, which even I cannot define. Sometimes I just am listening to the music and I realize, oh, wow, I really like this music. And I have never heard of it before. And I sometimes have to say thank you to the Spotify's recommendation engine for introducing me to those kind of genres of music in general. And also, going back to when it was launched, at that point, 2008, the end of the first decade of the 21st century, we had iPods. A lot of iPods were being used and YouTube was upcoming, but Spotify provided a midway. It was not as data consuming as YouTube, because back then data was not as cheap as it is today. And also, it was not limited to the music or to the songs that an iPod could hold. It provided unlimited music that was just a click away, and also not so data consuming. And over the years, Spotify has definitely grown a lot to establish a place for itself. And some other points that I really like and just wanted to mention before I end this is that it is way ahead of its competitors like SoundCloud, Google Music, Apple Music, etc. And numbers speak for themselves. And I also love some of their marketing strategies. In 2017, they launched this Wrapped platform that showcased that showed listeners their Spotify statistics and music choices. The nerd in me was definitely triggered by it. So they curated all the music that I had heard in that year and showed that this is the genre, or this is the artist I listened to most. This is the artist I discovered and fell in love with for his or her music. And that was very interesting to see my music journey in terms of numbers and statistics. And some other features that I like are Spotify Radio, Spotify Sessions, etc. Some features that I would like Spotify to improve in future is maybe integration of Spotify on Fitbit. I've not checked if it has already happened or not. I think I read somewhere that they were in discussions of it. And maybe in some way music videos can be integrated. I know if they integrate music video, it will become something similar to YouTube, but maybe music video not solely in the terms of just putting some artist's video, but maybe something more about related to art and not just music, because Spotify in their statement, in their goals, talk about they are a platform for artists, and artists are not just restricted to music, right? They're also about dancing, about painting. And I don't know how it can be done, but I think Spotify as a platform for upcoming artists in general could be a very interesting way to look at Spotify as a platform in future. So yeah, that was about my discussion for today. You can reach out to me on any of the platforms. On LinkedIn especially, I'm active, and I would love to hear from you what you think about it. What are your feedbacks, and how has your journey or experience been if you have interacted with product managers in your journey as in your career in general. So thank you so much for sticking around, and let's see if we have any questions.
Yes, thanks for the great talk, Shreya. We have some questions indeed in the chat, a longer one.
Yes, I can go ahead with those questions. So Robert asks, thanks for this insightful talk, Shreya. Thank you so much, Robert. You described that you can understand or manage the tech team better, having been a developer for some time, but however, how much pushback did you face from management or other product managers as someone who is new to the trade of management? That is, did you find the transition into management away from engineering easy? It was the first part, and the second part is, how easy was it for you to let go of doing things yourself versus enabling other developers to do it? Oh my God, the second question really hits a nerve, I think, but I'll answer the first question first. Definitely the pushback or stakeholder management or mismanagement as well sometimes is something that one has to work for and has to find that balance. It's not easy. And sometimes when you really try to push from a development perspective, the management side comes down on, we need to get things rolling. One thing that I found was that I had to take a different approach from both these roles was that in the development fields, where in the tech field where I was striving to create the best algorithm out there, now I want to focus on, especially in the first iteration, a running product or a running algorithm that can do the job good enough. And that, I think, is very important, and it was difficult for me to accept in the first place as well. But I think on the product side of things, when there is a lot of pushback coming from different fields, it becomes that how you handle that, and what is the trade-off, and what are you willing to sacrifice at some point. At the same time, having the development team convinced and motivated, it sometimes gets tricky, but it's an interesting balance. And when the end result is hopefully good, then everything falls into place, and people in the future hopefully trust you more. And how did I find the transition from engineering to management easy? I think it is a very personal question on what people like to do. If someone is really interested on the development or coding side of things, they would, and if they want to stick in that field, then that transition can be difficult. But personally, since I wanted to move into the product or strategy kind of things, I started taking up smaller roles in my role as a data scientist initially, and seeing if I liked it or not. So it was more of a 75-25 or 50-50 split in my role, where I talked to my manager if this was possible, and they were really nice to accommodate my interests. And that's when I realized that I like it. And once I realized that I really like it, and maybe like it more than the coding side of things, I decided to make a transition full-time. So I would say the transition was relatively easy for me, but it's a very personal experience. And to answer the second question, how easy was it to let go of doing things yourself versus enabling others? I think when you have so much tasks to do, when you're very initially doing all this, it is definitely difficult to do that. And it's difficult to let go and, not doing things yourself. But then when you have so much requests coming in, and you have to be in different meetings, and you have to understand what is happening so that the development team can actually do what they have to do, and so that we can proceed, then it becomes the need of the hour to let the developers do what they are best at. And also with time, you realize that, it's different roles are created for different tasks, and you have to trust your team. And trusting your team is the most important thing, be in good sync with the tech lead. And with all this, gradually with time, you start accepting that you have to let go of doing things yourself and trusting your team. And together you win as a team. And make things possible. And after a couple of iterations of successful or acceptable products, the team finds that balance. Everyone in the team understands their roles, and things become smoother in the long run. So I hope that answers your question, Robert. If you have any more questions, then let me know.
All right. Are there any other questions?
I think we are good then. And then we can quickly move to a short round of closing of the session as well. We had a great time today to have you all with us. And this was also our last event for this year. This year was definitely a very interesting one for all of us that showed us how interesting or challenging life can be. I'm sure we will look back on this year and remember this one for sure. And even for PyBerlin, we started with our online events last year, and this year it was all online. So thank you for coming and joining us for this event today. The speakers for today, Max, Anastasiia, Luben, and myself, it was great to have and listen to all your experiences. And it was, I'm sure our audience also liked it. Please let us know if you liked it or not. You can tweet about it or just let us know. And we would be happy to know how we can improve in future as well and make this experience more comfortable and enjoyable for you. This event, as Anastasiia mentioned, that was sponsored by Scoutbee. They have been an amazing host for our events, and a huge, huge shout out to the Scoutbee team for making this possible and helping us organize these events throughout the year. Next meetup, stay tuned. This was our last meetup for this year, but next year we will be back with more interesting events. Today we had all planned that this would be an in-person event, but unfortunately, because of the rising cases, we could not host it in person. But we really hope that next year, sometime maybe in March, April, we can see each other in person, see our community and all the old and new faces that have been with us on this journey. So stay tuned for us. Please stay in connect on Meetup, on Twitter, and we will be soon announcing our next date. Also, if you are interested in being an organizer at PyBerlin and helping understand and want to understand how things work behind the screen, we would love to have you. And please contact us if you would like to help on PyBerlin. Python is our Twitter handle, or just reach out to any of the organizers or on Meetup page, and we would love to have you. It's not a lot of work. I think it gives a lot of exposure to different people in connecting with, if you're interested to speak in or organizing them. And also you connect with so many companies where you look for sponsors. So it is definitely a very good networking platform to be part of this for some time and understanding how such meetups or organizations work. And trust me, it's not so much work. It's probably 3 or 4 hours of work for every meetup at max. And to be honest, Anastasiia does such a good job for us that we are really, really thankful and grateful to have her helping us out in organizing these events so much. And also we are looking for speakers and panelists. If you would like to share your thoughts and ideas or any project that you've been working on, then please let us know, again, through Twitter, Meetup, or you can scan this QR code as well and submit your talk proposal, and we will get back to you on a mutually convenient time and date so that we can have you on our platform to express your thoughts and ideas. And like I mentioned, and so did Anastasiia, we are on Twitter as well with the handle PyBerlin Python. So please tag us and let us know what you liked or did not like about this event. And we would be happy to incorporate your feedback and bring a more comfortable and enjoyable experience in the future. And that was it. Thank you so much for coming. See you next time. Thank you so much. Have a great evening. Have a great holiday season ahead. Stay safe, stay happy, stay healthy. Thank you so much. Good night.